Hey everyone, in this tutorial we are going to be learning about Google Cloud Composer, some more about Google Cloud Composer, and we are going to be learning about Apache Airflow and how we can use it to orchestrate some complex data workflows. We are going to cover some key concepts like parameterizing your DAGs, working with different Airflow components, and managing your task dependencies. So let's get started. So we are right now at my environment. You can see the name of my environment is Composer Airflow. We are on the Airflow version 2.7.3, and let's check out the code and understand more about it. So first we will learn about file processing and parameterizing and using a sensor. Right. So we'll go to our first DAG. I've named it DAG1 parameterize. This DAG is to parameterize a file path. We're going to process the file and we are going to use a file sensor. And we're going to talk about each of these things as we go along the tutorial. So we are using a Python operator for the first task. It's a read and it's going to read serialized task. Basically read the data from the file and serialize that data. We have written a Python function for that. Read and serialize return. It calls this function in which we are using a GCS hook. A GCS hook is a Google Cloud Service hook, and we are going to use this hook to download the file from a particular bucket and the object. Let me talk a little bit about what's a bucket and the object. Now this is my Google Cloud storage. Let's see. So here this is my bucket and the rest of the part DAG/Airflow, that will be my object name. And I have uploaded my lab and my functions file. We'll talk about that more later on. Coming back to this, we are using a GCS hook for downloading our file. We are going to log the file in content, and then we are using pandas to read the file, and we are going to convert it to JSON and return the serialized data. That completes the first task. Now we have the second task. Now in the first task we have this OP quarks. Now the in Python quarks are keyword arguments. So this is my this is my key and this is my value. I can pass this in the function. So this will be read as quarks here, and my file path I will get it from the quarks. When I search it, when I look into the keyword arguments with this key, I will find my path to the file that I have kept in my task. Alright, we are using split to split the bucket name and the object name. And the GCS hook you can import from Airflow provider .google.cloud.hooks.gcs. You would have a lot of different hooks. You could check out all the hooks in the documentation. Coming to the second task, it is a process task. So now we have our file, we have read our file, we have serialized it. Now what's the next step? We're going to do some processing on that file, right? In real world scenario, you would write smaller functions that each have one particular responsibility. In this case, the first has only the responsibility to read and serialize the task. Second one processes the file. Now here in the keyword arguments we have given the output path. Now let's see what this output path is actually. It is a data slash DAG processed file.csv. So this is the processed file. In the input we gave the path as processing file. Now in Google Cloud Storage GCS, you'd have two paths. One would be DAGs, one would be data. All of your CSV files, everything would go into the data path. This is my processing file and this is the process file. Let me delete this file for now. When we run our Airflow tasks, when we run our tasks, this file should get created on its own, right? Okay, now coming to the process task, we're going into this function. We're using serialized data. We are using the X comps. This is a powerful feature in Airflow, and this is basically used to share data with in between the tasks. Okay, so see, this is our we find our serialized data like this from the task before, right? The read serialized task, the output of that. So this is our serialized data. We're just going to read that data into a data frame, and we're just filling all the null values with 1, and we have the output path that we kept in the task, again using the GCS hook, and we are going to simply upload the file, and we are logging the processed file. So uh, it's a good practice to use loggers in your code instead of print statements. And when you're logging your whenever you're logging, you should make sure that this part is correct. This is the info log. You have warning, you have warn, you have error, you have exception, you have critical. All of these have different use cases. For example, we are using info here because it's an informational log. Let's say there's an error. Then you should not use logger.info to log your error. You should use logger.error. And you might ask, why not just keep info everywhere, right? But whenever you're logging a lot of things, um, you have a cost to pay for your logs. So you'll have Google Logs, right? Whenever you log a lot of things, it logs based on the size of your logs. When you're using logger.error, you could set an environment variable to only log the info logs when your system is running. If you want to uh, print out your error logs or critical logs, you could set the log level as debug, right? Moving ahead, we would go to the file sensor task. Now here we are using a GCS object existence sensor. We are going to import it from airflow.provider.google.cloud.census.gcs object existence sensor. What this sensor does is it waits until the processed file exists in the location that we have mentioned, right? And we have set it to check every 10 seconds. This is the interval that every 10 seconds this sensor would keep on checking that is my file at this particular location, right? And this is the timeout. We have set it at 300 seconds. After that, we will this task will fail. It will time out basically. And whenever it's a success, we are logging it using the log file sensor output. We'll check this out as well. So these are all bunch of log statements. This is my task, the ID of the task. We'll say this has completed, the state of the task, start date, end date, execution date, and the log URL. Okay, and then we would uh, schedule them like this. This one would run first. The read serialized task would run first, then the process task would run, and then the file sensor task would run. Now let's talk a little bit about what's the benefit of using a sensor like an object existence sensor. So let's say you have we'll continue with the example of an ETL pipeline. You're in the transformation stage. You read data from a path in Google Cloud Storage. You make some transformations on it, you clean your data or do whatever processing you want to do on that data, and then you would upload it to a particular location, right? In the example that we are using right now, I would show you the files. We are only using 5 rows or 4 rows, right? But in real world scenarios, when you're working with uh, real data, you might have millions of rows. It's not going to be instantaneous. So it will take some time for the file to get uploaded there. And for our load phase of ETL, we want to wait till the transformation part has succeeded and till my file is in that location. Because if my load task starts before my file has been uploaded, then it's going to fail. So we use a sensor in that kind of a scenario. So we have a bunch of sensors. This is an existence sensor. It checks if that exists. This would be useful when you are creating new file at a new location. Let's say you update one particular file at one particular location all the time. So you don't need to use the existence sensor. You have to use the update sensor there. You also have sensors for to sense when an object is deleted. You would have a sensor for other services as well, like your Google BigQuery. You could use a lot of them in your code. So this is about the first part, about parameterizing DAGs, about sensors, and how you could upload, how you could process a file and then re-upload it. Right. Now coming back to the second part, we'll talk a little bit about different operators that we could use uh, in Airflow, right? So we could use what the things that we could do in particular operators. We talk about that. So the example we have are is one HTTP request, and the other one is a file operation basically. File operation simply reads the processed file that we created earlier and prints it out. But the HTTP request function, it uses Python's requests library to call an API. Well, let's check this out. So this is the URL, and it's going to print out the status code and the text from the response of that API. This is our API. If you want to see the output of it, you could also open it on a browser. It should work. So this is the data, user ID 1, title, and completed. And the status code for this would be something like 200 status code. It means it's a successful status code. And this is the file operation. This is our file path. We are using parameters here to pass the data, and then we would just log the contents of the file. That's all. So we are again using GCS hook to download, and also we will download it, then decode it, and then print the file content. Now another important thing about Airflow, like another important feature I would say of Airflow, is that you could schedule your tasks in a particular fashion. Like you could set up task dependencies. It could be upstream, downstream, and you can use something like this called a bitwise operator. You could also use something like set upstream, say something like start task dot set upstream, and then give the name of the second task to do something like that. But bitwise, I'm using bitwise operators here, and the reason we use this is because it's more convenient instead of and more readable. So when you read this, you understand that what's going to happen. Now, when do we use the square brackets? We use it when we want to make sure that as soon as the start task completes, these are the downstream tasks. This bash task and branch task, these two should trigger as soon as the start task finishes. Now as soon as the bash task finishes, it will trigger the middle task, and as soon as middle task finishes, it will trigger end task. Branch task, after it finishes, the end task will get triggered. Now there's one more thing in the task here, that is called trigger rule. This is the trigger rule. You have bunch of trigger rules here. We are using all done here. It means that as soon as all of these tasks are done, the middle task will get triggered. Now what's the benefit of this, right? We are going to use this all done. It can be used to as a cleanup kind of a task, right? We have, if we process a lot of files in the memory, if we create a lot of temporary files, we can use this task as a cleanup task that delete all the temporary files and free up some space. Apart from that, we could use it as a we could use another trigger, that is something like on when one of the when one of the task has failed, we could use one trigger. When all of the tasks have completed, we could use one trigger. Or when only one of them has been successful, we could use a trigger for that. It would be different kind of a trigger for all of them, and that's the use case of a trigger, right? And some yeah, we'll talk a little bit about our tasks here. We are using dummy operator. This is just to make as a placeholder to make our tasks clear. This is a bash operator. We are going to print a bash command, and the middle task, just log that. And this is the branch. So when we wanted to show branching. Okay, now let's go to our Airflow UI and trigger these tasks. So one thing that I would like to talk about here is in the DAGs folder, where you are uploading your Airflow lab2.py. This has all your tasks and DAGs, but this other file has all of your functions. So this would have been one question, like in Python you have something like an init.py inside of a folder. What's the use of init, right? Init is used between the folders so that Python treats this as a module. So you can import things between the files and between the folders. But we don't have any init here. I can't see any init here. But this is how you can use it. DAG functions.py, af.py in the same one path, and our data files are going to be in that data slash path. Yeah, in this path. Let's go to our Airflow UI. And I'm going to trigger these tasks. Right. Okay. Let's open up the first one. Graph. So this is the order of execution. Read and serialize. Let's see the logs for this. So the file contents, these are the columns in the file: name, age, city, salary, and the 4 columns here. So see, one thing is that in this part we have some null values. So this is where this is the part we are going to be processing. Now the important thing to note here is that it should always return an exit code of 0. It means that it's successful. Exit code of 1 means it failed. Let's check out our process file task. Exit code 0, and the third one is the sensor task. This also exited with a code 0, and we are logging the URL URL for the sensor. Now we are using GCS hook.upload here, so this should have processed the file and uploaded it into the GCS. So let's check that out. Let me refresh this. Data. So we can see that we have our processed file here. This is the current time, right? We can check it out. This is the processed file. As I was saying, this has filled the null values. All right. Coming back to other DAGs. This is our file in HTTP. The graph for it, file operation, and then HTTP request. See the logs for it. It exited with status code 0. Now response status code is 200, and the text in the response is the following that we saw, right? And this is a status code of 200 means it's a successful status code. It's a successful API call. Let's check out the file operation. Logs for the file operation. It also says that it exited with 0, and this is the file data, the output file data. The exactly what we downloaded. Going to the third tag about the dependencies. See the graph. Now as soon as the start task runs, it triggers bash operator and the branch task, and you can see the end task depends on the middle task and branch task. So end task would trigger after the branch task and the middle task have successfully completed with an exit code of 0. Let's check that out. Task, this one executed with 0. End task. Let's see the middle task. Middle task also exited with code 0, right? Yeah, so that's all about the intermediate tutorial. One thing that I would like to mention here, it's a trick. It's not necessarily a trick, but it makes your life more convenient. So whenever you're using this IDE or a text editor, I'm using VS Code, you should set up your Python environment. I'm using Airflow environment, and I've also set this Python interpreter. So you could do Command P or Control P on this based on the system that you're using, and select Python interpreter and use your path here. This is my path, selected interpreter, Airflow in Python. So the benefit of this is that I can see the code inside the Airflow library. Now why would I want to see the code inside Airflow library, you might ask, right? The reason is that, let's see, one very nice thing here is there be an example of DAGs. This example DAGs. So example bash decorator. Right? Whenever you want to use bash decorator, how should you use it? You should use it as they have given it here. You want to use something else. Let's say, what will we see? This is a tutorial DAG. So, tutorial DAG, right? Basically, you're learning about this. So you could refer to this. They give this to you, that this is my tutorial for you. Extract, transform, load, and then let's see the dependencies. So extract, transform, and load task. Load task, Python callable load is going to be using this, and this T that you see here is the XCOM, is the cross communication that we talked about, T.XCOM pull. So this is going to pull the output from the transform task ID that executed before the load part. This is going to push, and this is going to pull it from there. That's all about the tutorial, and I hope this sparked your interest, and make sure to check out the Airflow documentation for more possibilities on what you could do with Airflow. And if you have any questions, you could reach out to me or paste it in the or ask those in the comments as well. Thank you.